All right, welcome back, students. Hopefully, if you are watching this video right now, you have already answered these 6 questions because you've already watched the first video. And at the end of that first video, we said that we wanted you to do these on your own and then compare them to the answers that I give you. So if you remember to the last video, I said that the sticks are going to represent our variables and that the boxes or the circles are going to represent our leftover whole numbers, just numbers, no variable attached to it. So what this looks like then is this is going to be an x, an x, an x, and an x, and these are just the leftover whole numbers at the end. So if that's the case, I've got 4 x's, so 4 times x, repeated addition, plus the 3 that are left over. So pretty straightforward, just simply looking at the picture and converting it into an expression. This one I see 5, and again, doesn't matter the order, 5 individual numbers, no x attached to it, plus just 1 x. So I can represent that in this format, 5 plus x, or I can put the 1 in front of it. Means the same thing. Anything times 1 will get us back to the original number. But I'll show you why that 1x might matter to us in about a couple minutes here. Last one here, I see 3 sticks, so that's going to be 3 variables, 3x, plus the 3 boxes left over. So again, I think pretty straightforward, pretty simplistic. Hopefully that was relatively easy for you. Now I'm going to show you the other way. I'm going to take the expression, I'm going to convert it into our picture. I'm going to take it into our model. So now whenever I see an x, I'm going to represent whatever number is attached to that x as a stick. In this case, there's 1x, so I put 1 stick, and then I'm going to represent it with however many whole numbers I see, or numbers without a variable attached to it at the end. Those are the leftovers that don't belong to the box. So 1 plus 6 boxes. Here again, we've got 4 x's, so 4 sticks, and 1 box left over. Now, no matter what I put in for x, I've got that many sticks, so let's say that x was, in this case, 2. That means each of these sticks would represent 2. So it'd be 2, 2, 2, and 2 for a total of 8, plus the 1 box left over. That's how that would work. All right? And then again, the order does not matter. So in this case, I've got the only number out front, so that becomes the 3 boxes. And then I've got the 2 sticks at the end. So as I copy it down, I should just write it down how I see it, even though it may look a little weird to have the boxes first. All right, now, how can I combine like terms? What does it mean to combine like terms? So as I look at this next idea, this next concept here, the question is basically true or false, or yes or no. It says, would x minus x equal 4? And I can see a logic behind it. I see an x minus an x, so that should automatically cross each other out. The drawback, though, is we need to be thinking about, order of operations. The x that's connected to the 4 will be done first. So that technically isn't an x anymore. That is going to be absorbed by the 4. And so I have to then understand that when I subtract an x, I'm no longer subtracting from, or just not going to leave me with just a 4. It depends on what that x was. If that x is a 2, it doesn't work that way. So what this actually is I'm combining like terms. I see 4 x's here, and I'm taking one of those x's away. And this is where I said sometimes writing that 1 in front of that variable helps us to understand what we're combining here. I'm not just getting rid of all the x's, because this is being represented by 4 x's here, but what I am getting rid of is just one of the x's. So it shouldn't equal 4. What this should equal is 3 x's. All right? So hopefully that again makes sense. We are combining those like terms in that situation. We're bringing it together and removing one of the variables, and that's not removing the variable in general. It's just removing one of the variables. Okay? Think again, kind of order of operations to help you in that scenario. Here's another way to look at it. In this situation, if I've got 2x plus 5, or I've got 2x plus 5x, those mean 2 different things. I can't combine or simplify this any farther because this one has a variable in it and this one does not. This has a vacant area behind it. Those 2 things are not like terms. They don't share that variable. They're not combinable. I can't shrink it down. The bottom one can. I've got an x in both of these scenarios and they are like terms. They're both variable connected pieces, and they're both the same variable. It's not an x and a y, so I can combine them. So which of these would combine to create 7x? Well, I can't. I just got done telling you I can't combine the top one, but the bottom one, if I take 2x's and I put them together with 5x's, it's going to get me to the answer of 7x's. Okay, so this is taking us to the concept and the idea of what we call combining like terms. Things that are similar to one another, we can shrink and get down to a different level. All right. I'm going to skip over a few things here. I skipped over the bottom of that page just for time's sake and kind of what we think we need to know here. I'm also going to skip over parts of this, but we are looking at two expressions here. We see 4 plus 3d, and we see 2e plus e. All right? So again, as we look at those, we think, can we combine these anymore? Can we move them around? And that should be in our mind. But it's not the key to what I want to do here. I want us to represent all or find all the different expressions that are equivalent to the two that we see here. All right, so I've got some listed underneath here, and I will show you those as I pull this down, but I want you to be looking at this and thinking about, okay, how else could I write 4 plus 3d? Or how else could I write 2e plus an e? Okay? So hopefully you've got that in your mind. You've been thinking about that. I'm going to take that down. I'm going to expand this up to bring it up a little higher here. And you can see the situation's already been filled in for us. I'm going to skip over the diagram part because I think, again, the concept in general is easy enough for us to understand. But in situation 1, you can see that Mark has 4 random bananas. He doesn't have 4 bananas in each. The each part, the in each, is connected to our variable. Okay, so this is where the 3 boxes with D bananas. Now, D could be anything. D could be 1, D could be 4, D could be 5. D could be any number. But it's in each, which means that's the multiplication piece. And I can't combine something like that if the other one is just loose bananas laying around. I can't put those bananas into a box. Okay, because that changes up my each number. What I would like us to look at here is the bottom section. So as we look at 4 plus 3d, which of these other expressions on the bottom here also represent 4 plus 3d? The same thing. They're equivalent. Again, key word here, equivalent. They mean the same thing. Well, 7d, that would be like the example I just gave you. That means I'm combining the 4 and the 3, but I said I can't combine unlike terms. The 3 has a d attached to it. The 4 does not. Those can no longer get any smaller than what we see. So this one cannot work. All right, let's take a look at the next one. I've got the 4 by itself, but now I've got a 2d and a 1d. I can combine these down to get to be 3d. Well, there we are again. Now I've got 4 plus 3d. This one works. It is the exact same number. And the same thing with this last one. The 4 is by itself, but if I combined these 3 like terms, I'm going to get to the same exact answer as I had before. 4 plus 3d. These things all mean the same expression. So the next one, as I look at this, 2e plus e, now I've got those like terms that are e's. So which of these are also going to represent the same idea? Okay. For me, it helps me to just look at it and try to see, can I simplify what I see here? And I can. I know I got an e and an e. So 2 e's plus another e is going to get me to 3e. So that they show me that already. So 3e should be a gimme. Should be an automatic that I see that. The other ones might not be as easy. I see a parenthesis in there. Okay. But here's the thing that I need to recognize. If I've got a 2 separate here without the e's attached to it, okay, I can no longer combine that 2 to the e's because the e is no longer an attachment to the 2. It's no longer in that same term. So this one cannot be an equivalent expression. Whereas this one, again, contains nothing but e's. So when I combine these, this is going to get me to 2e plus 1 more e. And again, I can combine them all the way down to 3e if I want to, so I can see the equivalency there, or I can see that that is also the equivalent expression that I've got up here. I know I'm kind of, again, talking a lot here and talking about combining and all these kinds of things. The biggest identifier you guys can make, or the biggest thing I want you to look for is, do I have a number standing by itself, or do I have a number attached to a variable? I can attach and connect variables and simplify things down depending on what it tells me to do. In this case, add an e to an already existing e. I cannot combine the 4 that doesn't have a d attached to it to the d's that already exist. All right. Same situation here. I'm not asking us to come up with a situation, again, just based on time constraints. I'd like us to look at 14 and 15 though. So I've got a 5 and a 1 that don't have a variable, and I've got a 2 that does have a variable. So how could I combine that? What would be an equivalent expression? And the best way for me, like I said, is to simplify it down to its easiest form. Combine what you can combine. And that should give you one of the answers. And then I can look at the others and see which means the same thing as that. So if I'm combining like terms, this 5 and this 1 can be combined. The 2 cannot because it is attached. This is a whole term together, and that's got a c attached to it, which these don't. So the simplest form of this expression will be 6 plus 2c. Well, I see that one right here. So there's my one equivalent expression. Now, which of these other ones also means 6 plus 2c? Well, 8c does not, because again, I can't combine the 6 and the 2. They don't have like terms. This one does, because again, the 2 and the c will come together like they are already. This means 2 times c, okay? And the 6 is separate. So this one means the same thing. Now, the next one, 6 plus c, again, kind of confusing, but I can combine those like terms, right? So I see a c and a c here. These can come together to be 2c. The 6 I cannot combine. Well, that's an identical expression to this one, so this one would also qualify as an equivalent expression. All right, same thing on the next side. What can I combine and what can't I combine? Well, I've got one number up there with a variable, the g, and these two do not. So these two are combinable where the other one is not. I can put the two whole numbers together. So the simplest form of that expression would be 3g plus 6. Do I see a 3g plus 6 here? Yes, I do. Can I make that together to make 9g? No, because the 6 does not have a g attached to it, so this one cannot work. And again, this last one, what does 3g stand for? It's a repeated addition problem of 3g's, 1, 2, and 3g's, with the 6 separate. So this one would also work. Okay, so we're simply looking for what can I combine, or what can I break apart, and that's some of our addition and multiplication ideas, all right, as we go forward there. Okay, and then one last thing I want to go over in this video before we get you started on an exit ticket or an assignment here. So I'm going to skip a couple questions, but you can definitely go through, excuse me, went a little too far. You can definitely go through and ask your teacher to help you with some of those other problems, or use the other ones as some examples to practice for sure. But this one here says write an equivalent expression with fewer terms if possible. So there are two here that I can combine and simplify. It says combine, right, with fewer terms, and two that I cannot. Two that it's just not possible to combine them. So I want you to identify 22, 23, 24, and 25. Which two can I combine and which two can I not? And I think that will really drive the point home to understanding this concept. I'll give you about 10 or 15 seconds here to be thinking about that. All right, hopefully that was enough time to kind of look at those 4 questions. I know I'm kind of rushing you here, but I've also got a time limit that I need to get through this video. So, as I look at these 4, I need to look at which ones of these have a variable in both terms. Those are the things I can combine. So in this case, I can combine this one, and I can combine this one, but I cannot combine these two. So this is not possible. Not possible. This one can shrink down to 5m because I'm taking 6m and I'm taking 1m away from it. And this one can be shrunk down, or I say it's shrunk down even though it's adding. I'm combining them to say 4s's plus 4s's gets me to 8s's. Okay, they have a like term, they have that like variable. I can't combine regular numbers with things that have a variable attached to them. I'm looking for things that look the same and I'm combining them. All right, good luck on your assignment today. This is just an introduction. We will continue with this concept for the next couple of days, but good luck and ask questions of your teacher if you have them.